What's up you guys? In today's video I'm going to be sharing with you everything you need to know to build a split mechanical Corne keyboard yourself. We're going to be putting together the Cherry Corne version 3, which supports MX compatible switches with Kailh Hotswap sockets, so you can easily insert and replace switches whenever you want or need to. And it also has support for RGB lighting under each switch on your keyboard, as well as Underglow RGB lighting and OLED screens. I'll be sharing with you all of the different parts that you will need to build this keyboard, as well as the soldering equipment that I personally use for this. This is not a soldering tutorial per se. I'll have links to helpful soldering tutorial videos that have helped me in the past in the description, though I will show you how I personally solder and install each of the different components onto the PCB. After we build and assemble the Corne, I'll also show you how to flash and program your keyboard with firmware like QMK so that you can start using your keyboard and customizing your layout however you want. Putting this together does require some effort and monetary investment. The enjoyment of using a keyboard you built yourself on a daily basis is pretty awesome, and the improved ergonomics and customizability of a keyboard like this, I believe, makes it worthwhile. Alright, so the first thing we need to get out of the way are all of the different parts that you'll need to build this keyboard. The first thing is the PCB or printed circuit board for the Corne. You'll have two of these, one for each side of the keyboard. Now on the PCB you'll install several different things. The first of these are 42 SMD diodes. You'll also need to install 42 Kailh MX Hotswap sockets. Now you'll also need two TRRS jacks, one for each side. You'll also need two reset switches, one for each side again. Now optionally, you can also install 12 RGB LEDs for the underglow lighting and 42 different RGB LEDs for the lighting underneath each switch. Now the easiest way to get all of these different parts is to purchase a kit for the Corne. Typically these kits include all of these different parts together. Now I found that when building the Corne, some of the trickiest components are the very small diodes and especially installing the LEDs. The soldering process for installing the LEDs I found to be pretty tedious and challenging, and if you don't get the orientation of these LEDs correct, your keyboard won't function properly, and I've also found them pretty hard to desolder and remove from your keyboard. Because of this, I've put together my own kit that already has the diodes and LEDs soldered onto the PCBs to make the process of building this keyboard easier. This kit is available in the US in my online shop called Split Type. I'll have links to both the regular Corne kits and this partially assembled kit in the description. For the purpose of this video, I purchased a regular kit so that I can show you how to assemble all of the different components, including the diodes and the LEDs. You'll also need two microcontrollers for each side of your keyboard. You're typically gonna want to purchase either a Pro Micro or Pro Micro compatible microcontroller. My recommendation and what I'm going to be using in this video is the Elite C, which can replace a Pro Micro and has a sturdy USB-C connector that won't get ripped out when you're connecting or disconnecting a cable to the microcontroller. Now you can solder the microcontroller directly onto the PCB, but a better option is to socket your microcontroller so that you can remove it from the PCB if you need to, or replace it with another one. To do this, you'll need to purchase a socketing solution for your microcontroller. In this video, I'm going to be using low profile sockets and Mil-Max pins. Now optionally, you can also purchase OLED screens for each side of your keyboard. There are some other things that you'll need to finish your build. The first is a case for your keyboard. There are different options ranging in price. I personally have put together a 3D printed case for the Corne that comes in either a tinted or a regular version and has an optional honeycomb pattern that is designed so that the RGB underglow lights on your keyboard can shine through. The honeycomb pattern works best with a tinted version of the case so that the space that the case creates between the keyboard and the desk allows the light to pass through. Now optionally, and I would recommend this, you can purchase a display cover to protect the microcontroller section of your keyboard and also protect your OLED screens if you've decided to install these on your keyboard. If you have the OLED screens, you should go for a transparent acrylic display cover, and if not, in the US I also have available 3D printed display covers covers to match the color of your case. I'll have links to all of this in the description. Now your keyboard will also need switches and keycaps. These both need to be MX compatible. I like to use blank PBT keycaps with a DSA profile. The DSA profile is nice because it's a lower profile and the keys are all the same height, so you can arrange them on your keyboard however you like. I have options for black or white keycaps on my shop, as well as additional accent colors. I'll have links to the keycaps I'll be using in this video in the description. I'm also going to be using Gateron Milky Yellow Pro switches, which are linear and are pre-lubed from the factory. I really like how these feel and sound. They're pretty smooth and quiet. They're also available in my shop in the US. The final two things you'll need are a TRRS cable to connect the two keyboard sides and a USB cable to connect your keyboard to your computer. Alright, before we begin, I want to also mention some soldering equipment that I'm going to be using in this video. The first and most important thing you'll need is a soldering station that has adjustable temperature. I have a Yihua 926 that is relatively affordable from Amazon. It's honestly worked really well for me. It comes with a good amount of stuff like some lead-free solder wire, a desoldering pump, 6 different soldering tips that are really nice to have, some tweezers, helping hands, and a cleaning sponge. This is the tip that I'm going to be using in this video. I found it to be pretty nice for building this keyboard. Now this will have most of what you need. Some other items that I would recommend include a solder wick to make it easier to remove solder from your PCB if you need to. I would highly recommend you get some no clean flux. It makes the whole process a lot easier. And I'm also going to be using some precision tweezers from a set that I bought from Amazon. It has a bunch of different tweezers that come in handy, especially reverse action tweezers. These tweezers really come in handy when installing SMD components like the diodes. You can use the lead-free solder that is included with the soldering station, but if you can, I'd recommend you upgrade to some better solder. I would recommend both 0.8mm solder and thinner 0.5 or 0.6mm solder for working with SMD components. You should also get some heat-resistant tape to help secure some of the components before you solder them onto the PCB, as well as wire cutters and optionally a soldering mat to help protect your desk. You should also avoid breathing in the fumes. I would work in a well-ventilated area, and I recommend use a fan to blow across your workstation to blow the fumes out of the way, and preferably out a window. If you're working in a closed space with no ventilation, then you can also invest in a small solder smoke absorber, which helps prevent you from breathing in all of those fumes. These are just my recommendations. It's stuff that you'll be able to use for any other soldering projects that you want to work on or want to build other DIY keyboards that you're interested in the future. Now I personally set the temperature of my soldering iron between 350 to 370 when working with lead-free solder. You should tin the tip of your soldering iron the first time you're going to start using it by applying a coat of solder to the tip and then cleaning it off on a damp sponge. Make sure that the sponge is damp and clean. It's important that you tin your tip before you start using it, and I also apply a coat of solder before I put it back into the holder to prevent oxidation. Whenever I pick it back up to continue soldering, I clean off the tip and then continue working. Oxidation is your worst enemy and will make soldering a whole lot harder. Now let's get started building this keyboard. Alright, so the first thing you want to solder onto the PCB are the diodes. To do this, I like to press my soldering iron onto one of the pads to heat it up, and then I feed a small amount of solder onto the pad. Now it's important that the diodes are installed in this orientation where the line on the diode matches the line on the PCB. I'd recommend you use the reverse action tweezers to pick up the diode. We'll heat up the pad that has some solder, and while the solder is melted, you can place the diode where it should go. Then you first remove your soldering iron and then your tweezers. If the diode's position isn't quite right, you can grab it again with your tweezers and then heat up the solder with your soldering iron and then fix the positioning to where it should go. Again, removing the iron first and then the tweezers. Then I like to turn the PCB around and then heat up the other pad with your iron and feed in a small amount of solder onto this other pad. If you've added too much solder, you can apply some no clean flux to the joint and press down with your soldering iron on a solder wick so the wick can absorb the solder and remove it from the PCB. And again, you can heat up the pad and feed a small amount of solder in. Now you just need to repeat this process with the 41 other diodes. Now the next step would be to install your Underglow LEDs. They have to go in this orientation where the recessed corner of the LED matches the marked corner of the PCB. Now very similar to the diodes, you'll want to heat up one of the pads and feed a small amount of solder in. Then I recommend picking up the LED with reverse action tweezers, making sure you pick it up in the right orientation. Then you'll heat up the pad to melt the solder and place the LED where it should go. Again, removing first the iron and then the tweezers. What I like to do next is apply a small amount of flux to each of the other 3 pads. Then I melt a small amount of solder to the tip of my soldering iron. Then I flip it over so the solder faces down and I press the iron into one of the pads. The flux helps make sure that only the right amount of solder is applied to the pad. Then I do the same thing to the rest of the pads that are left. I do this a couple of times with a small swiping motion, and if the joint needs a little more solder, I add some more to the iron and then do it again. There's 1 pad left, so again I just do the same thing to melt some solder onto the pad. You want your joints to look something like this. Make sure that you have good joints, because if not, not only will this LED not turn on, but the rest of them might not either. Now you should repeat this process for the rest of the Underglow LEDs. There are 6 on each side. Once you're done, next you should install the LEDs that will light up each of your switches. The LED has to go in this orientation where the light will shine to the other side, and the notched corner of the LED matches the marked corner of the PCB. Again, you'll want to heat up one of the pads and feed a small amount of solder in. And then I pick up the LED with regular tweezers, not the reverse action ones. And then I put it where it should go, pressing down on the center of it with my tweezers. And then I like to melt the solder with a sort of swiping motion, using the tweezers to adjust the positioning of the LED. And then for the rest of the pads, I heat them up with my soldering iron and feed a small amount of solder in. And I like to use a sort of swiping motion to help clean up the joint. Then I repeat this for the remaining 2 pads. You might accidentally create a bridge when you're doing this. I'm just gonna create one here on purpose. To fix it, I like to apply some flux to the bridge and then I melt it with my soldering iron. And again, I like to use the same sort of swiping motion to clean everything up with the help of the flux. Then you'll repeat this process with the rest of the LEDs. There are 21 on each side. It'll look something like this with the diodes and LEDs installed. This is also the starting point if you're using my partially assembled kit. Next, we're gonna install the Hotswap sockets. Again, I like to heat up the pad and then feed a small amount of solder in to cover up the pad. Then after picking up a socket with regular tweezers, I melt the solder with my soldering iron and bring the socket in. I let go. I like to press down on the socket with my tweezers as I heat up the solder with the soldering iron, keeping the iron near the edge of the pad so the socket sits flush. And then I first remove the iron and then the tweezers. Then I flip the PCB over and then apply some heat with my soldering iron to the other pad. I typically keep my iron near the edge and feed some solder through the side. Your joints should look something like this. Then you repeat this process for the rest of the sockets. There are 21 for each side. Now make sure to flip your PCB over to the other side. We're now going to install the TRRS jacks. Let's go ahead and place it on there. Then we'll get some heat resistant tape and use it to secure it into place. Then I flip the PCB over and I heat up a pad and one of the legs and I feed some solder in. You want the joint to look something like this, and then you repeat the same process with the rest of the legs. Then you can flip the PCB over and remove the tape. Next, we're going to install the OLED screen socket. Again, we're going to use some heat resistant tape to secure it into place. You want to make sure that it's straight and all the way down. Then flip the PCB over and solder the pins in. And then go ahead and remove the tape. The next thing we're going to install is the reset switch. We're going to place it in and again secure it with some heat resistant tape. And then flip the PCB over and solder the legs in. Then flip over the PCB and remove the tape. Now we're going to install the microcontroller to the PCB. You can use the pin headers that come with your microcontroller to solder it directly to the PCB. You can insert these long side down onto the PCB, but I'm going to show you how to socket the microcontroller, so we're not going to use these. Instead, place one of the sockets for your microcontroller onto the PCB like so, and secure it into place with the heat-resistant tape. Some sockets fit snug. If they're a little loose, make sure that they're straight and flush with the PCB. Then you can flip the PCB over and solder in all of the pins. The tape should be helping with this, but before doing the rest, make sure that the socket is sitting correctly. If not, heat up the first joint and reposition the socket as needed. Then repeat this process with the other socket, securing it in with tape and soldering in all of the pins on the other side. Then I like to use flat tweezers to pick up one of the Mil-Max pins. Once I pick it up, I like to use my fingers to rearrange the pin on the tweezers, and then I drop it into one of the holes in the sockets, and then I close my tweezer to push down on the top of the pin. You should hear it click into place. Then go ahead and insert the rest of the pins. Once that's done, you can take your microcontroller and place it in like so. All of the holes on the sides of the microcontroller should have pins except the one closest to the front, and the microcontroller's logo should be facing up while its chip and the other components on it are facing down. Then you can go ahead and solder the pins to the microcontroller. If a joint has too much solder, then you can heat it up and use a desoldering pump to remove the solder. And then you can redo the joint. Now to unsocket or remove the microcontroller, I like to use some flat tweezers. I like to bring it in under the front and pull up softly against the USB connector, and then put it under the back and pull up softly against the edge. And then I repeat this, alternating between the front and the back until it's out. The bottom will look something like this. Alright, let's put it back in, placing it where it should go. Make sure you place it correctly before pressing down to prevent bending the pins, and then you can press down on it to put it back in. Now we're going to install the OLED screen. The ones that I purchased have these diode legs. We're going to cut the legs like so. I'm using wire cutters for this. You're going to be using 4 legs in total. Now you can pick one up with one of your tweezers and push it into one of the socket holes. You should hear it click into place. Then you should insert another leg on the opposite end, and then insert the OLED screen through these 2 diode legs like so. Then you can insert the remaining 2 diode legs. Then you can solder the first leg to the OLED screen, and if necessary, heat it back up to adjust the position of the screen and make sure it's flat. Then you can go ahead and solder the rest in. Then you can cut off the excess with wire cutters. I'll have these specific ones linked in the description. And then after you've installed all of these components on both sides, you're done. Alright, so now we're ready to flash our keyboard. I'm going to show you what I think is the simplest and easiest way to do this. Let me know in the comments if you want to see a future video on how to use VIA with your Corne and dive a lot deeper into setting up and using QMK. So I've opened up the online QMK configurator here. I'll have a link for it in the description. Up here you want to look for CRKBD, choose Rev 1 here, and our particular layout is going to be the 3x6. You'll see here that you have a couple of different layers. This is the first one, which is pretty standard. And then on the second layer, you have your numbers and arrow keys. The next layer, you have all of your symbols. And in the last one, you have controls for the RGB lights, as well as a key that can replace your reset button if you want to reflash your keyboard. You'll also see that on the base layer, this key here means that whenever you keep it pressed, it'll change the layout to layer number 1, which is this one. And if you keep this key pressed, it'll change it to layer 2. You'll also note that if you're on layer 1, so you're keeping this key pressed, and then you also keep this key pressed, you'll go to layer 3. Now you can change and modify this as much as you want or need to. To do this, you can click on a key and then click on the one you want to replace it with. Let's say I want to change this S with an O, and now it's an O here. I'm going to change it back to an S. There's a bunch of different options you can look at here with traditional keys, as well as special ones in this quantum section for changing layers and doing some more interesting combinations. And in this keyboard settings page, you have some keys for modifying the RGB LEDs as well as the backlight. And on this last one, I use some of these for changing songs with previous and next, muting my computer, changing the volume, that sort of media related operations. All right, so once you're happy with your layout, what we want to do is click on compile here. And then once that's done, you can click on this button here to download the firmware. The next thing you're going to want to do is to click on Get QMK Toolbox down here. Because we need to install QMK Toolbox onto our computer, you're going to want to look for the one that says Latest. And down here it says Assets. If you're on Windows, you can click on the .exe, and on Mac, the one that ends with .pkg. Because I'm on a Mac, I'm going to click on this one that says .pkg. Alright, then I'm going to go over here to my downloads and click on this last one here. And if you get this message on your Mac saying that it can't be opened because it is from an unidentified developer, you can click OK, and then open up your system settings and look for privacy and security. And you can scroll down here. You'll see here that it says it was blocked. You can click on open anyway and then click on open. Once this window pops up, you can click on continue, agree, install, and then close. Once you're done with that, you can open up QMK Toolbox. I'm going to do Command Space on my Mac and look for QMK Toolbox and open that up. The next thing you want to do is to connect one of your keyboard sides to your computer and press on the reset button so that you get a message like this one. And you want to make sure over here that it says ATmega32U4. If on Windows this isn't showing up, you can right click on the top of your window and then click on Install Drivers to install any missing drivers. This won't be necessary on your Mac. Now we want to open up the compiled firmware that we just downloaded from the online configurator. I'm going to click on Open here, and in my downloads, this is the one from the online configurator that says CRKBD Rev 1. I'm going to click on Open, and then you can click on Flash. Once that site is flashed, the lights should turn on as well as your OLED screen. Then I'm going to disconnect this side and connect the other side to the computer, and then again press on the reset button. You'll get the same message that we did earlier that says the device is connected. I'm just going to click on Flash again. And that's it. Now you've flashed both of your keyboard sides. Now if you want to test that all of your keys are working properly, you can go back to your online configurator and connect the left-hand side to your computer and connect the left-hand side to the right-hand side with the TRRS cable. Then you can click on Test Keyboard. Then you can flip the PCB over, and with tweezers, you can press the two metal ends to the two ends of a socket to short it, and you'll see it light up in the online configurator. You can do this for the rest of your sockets if you want to test your keyboard before finishing the build and putting it onto a case and installing all of your switches. If you're using the default layout, two of your keys won't get a response on the screen. It's the ones for changing the layers, because there's no way of showing it on this screen. And that's it, your keyboard is flashed. I'll also have a link to the firmware that I use if you want to use my setup. Alright you guys, so the last thing we have to do here is to actually install the PCB onto a case. Again, I'm going to be using this 3D printed kit that I've put together. First thing I'm going to do is to take these screws and standoffs. I'm going to take one of the screws and flip the case over and put it in one of these holes here, something like that. And then I'm going to flip the case over and I'm going to hold it in place with my finger and screw one of these standoffs in. You should have something that looks like this, and then you just repeat this for the rest of the screws and standoffs. Alright, once you're finished, you should have 5 of these installed on one side. Now I'm going to install a display cover onto the PCB. I'm using a transparent acrylic display cover. I'm going to peel off here the protective lining and then do the same on the other side. I'm going to put that aside for a second. I'm going to take one of these screws, flip the PCB over. It's going to go in one of these two. I'm going to put the screw in, hold it in place with my finger, flip it over. I'm going to take a standoff. These are 10 millimeters long. I'm going to screw this in. Then I just repeat this for this other hole here. This is what it'll look like, and then I'm going to take my display cover, orient it properly so that the holes match with the standoffs. Then I'm going to place a screw, and then with a screwdriver, you can use a Phillips number 1 for this. I'm just gonna screw this in here, and then I'm going to repeat this again, placing another screw here and screwing that in. Doesn't have to be too tight. And that's it. This is how it'll look like when it's installed. Now I'm gonna take my case and then place the PCB in like so. You'll see the standoffs pass through the holes for them on the PCB. And then I'm gonna take a switch plate and place it like this. I try to align the holes on the switch plate with the standoffs. And then I take a screw and put it over one of the holes on the switch plate. And then I screw it into the standoff. It'll look like this once it's screwed in. Then you can repeat this process for the rest of the holes on the switch plate. Alright, next we're going to install our switches. You should take a look at the orientation of the pins to know how they should go on the PCB. They should match the holes on your Hotswap sockets. In this case, they should go like this. You can just press it in and continue to do so for the rest of the switches. This is how it'll look like once you're done. Again, these are the Gateron Milky Yellow Pro switches. Next, I'm going to be installing my keycaps. These are blank PBT and DSA profile. You just have to press them into your switch like so. It'll look something like this once you're done. I really like how these black keycaps match the case color. Both of these items are in my online shop, and I like to use these accents to add a bit of color and to specify any special keys. This specific key will change the layer of my keyboard to the next one. I'm going to flip this over, and if you're using a regular case with no tenting, the last step would be to take these rubber bumpers. You'll take 4 of them and put them on 4 of the corners of the case, but because this one has tenting, I'm going to install the tenting legs instead. The shorter ones will go on these 2 holes and the longer ones on these 2. This is the difference between the two. One is 18 millimeters long and the other is 40. What I like to do is to insert it just slightly with my finger and then take my Allen key, which you'll probably need to use especially the first time you're doing this, and then screw it in. That's 2 short ones. Now I'm gonna do the longer ones. Once you're done, it should look something like this. Now before you move on, I would check that all of the legs are touching your desk and adjust them to your liking. Alright, then finally we're gonna take these plastic 3D printed caps and put them on the socket heads. They'll look something like this. Then you'll take the rubber bumpers. I'm gonna take one of them and then press it into the top of the cap. Press it in firmly so that it sticks, and repeat this for the rest of the caps. You'll end up with something like this. This is so that the keyboard doesn't slide whenever you're typing on it, and you can also use it on a glass table. Then you just repeat this process for the other side, and then you'll be done. Alright you guys, that's it for this video. Let me know in the comment section how it goes building your own Corne keyboard. I hope you enjoy your keyboard as much as I do. Don't forget to leave a like down below if you enjoyed the video. It really helps me out. And remember to subscribe to the channel to see more content like this from me. See you guys in the next one. Peace.